The last section, statistics, we'll look at is confidence intervals. A large part of statistics involves knowing how much accuracy you can put into survey results. Every survey conducted would contain a degree of error. You can't expect surveys to be completely accurate. And within this section now, we'll discuss some of the main issues around that. And that's called confidence intervals. And we use normal distributions to solve problems that involve confidence intervals. So the first point, it's not often possible to survey an entire population. If you're surveying an entire population, that would be called a census. And there's various reasons why census may not be done. If you're looking at interviewing people in the school on their favorite music group or some item like that, you may not have time, and it would cost a lot of money to carry out an entire census of people. Usually what happens is that a sample is taken. Another idea of a sample versus a census would be if you worked in a factory and you wanted to test light bulbs. You wouldn't go out and test every single light bulb that a factory produced. You would determine an accurate sample size and conduct your survey from there. Next point, we just cover that. So the population will give the most accurate results. If possible, you would look at every item or interview everyone where practical. And again, as we said, it may not be practical to always do that. Samples are not going to be completely accurate because of that, and they would involve a margin of error, and that's shown as a percent usually, and plus or minus. So if you carried out a survey and you knew your survey was accurate within plus or minus 5 points, that let's say you would expect that a light bulb would last 20 hours, plus or minus 5%. Well, you would have a range there when you would expect a light bulb to operate as it was expected. The larger the sample size, the more accurate the results. If you carried a sample of 1,000 light bulbs versus 100, you would expect that the sample size of 1,000 will be more accurate. And sample size is going to be determined largely based on how large the population is, and also the resources that you have available to you. And in terms of that, your ability to conduct a survey. A confidence interval is a measure of the likelihood that a result for a population lies within the range of the confidence interval. So how accurate could you expect the results of the sample to be? Would they have a 90% accuracy rate compared to the population, 95% accuracy rate, or 99%? And those are three common percentages used often in statistics. Okay, now that we have that done, we will do a short example. So a brand of battery has a mean expectancy of 12.6 hours with a margin of error of 0.7 hours. And we're asking what is the confidence interval? So the mean battery life, and this is a sample, so we would use X bar and not mu. So because it is a sample, use X bar. And a margin of error of plus or minus 0.7 hours. So we would expect a battery to last from 11.9 hours. So we would subtract the 0.7, or we could expect the battery to last up to 13.3 hours. So that will be our confidence interval from 11.9 up to 13.3.